B.Sc Part 3 and respected listener, a very good morning and welcome all of you to today's lecture. Dear students, first of all, may I have attention please towards on our previous lecture in which we were expressing the necessary derivation of LCO treatment of hydrogen molecule, and the topic which is taken from B.Sc Part 3 Unit 2nd, selected from Unit 2nd, titles as Molecular Orbital Theory. Dear students, in which our previous lecture we were calculated and we were deriving the necessary expression for bonding and antibonding molecular orbitals and its energy by using overlapping integral, resonance integral and Coulomb integral, in which our previous lecture of molecular orbital theory of B.Sc Part 3 physical chemistry, we have calculated bonding and antibonding energy levels for molecular orbital. Now I will calculate today. I will deliver today the lecture on the calculation of mixing coefficient of C1 and C2. Dear student, let us proceed today's lecture of B.Sc Part 3 by using the normalization condition. As you know, in our previous lecture of Unit 1st, the fundamental postulates of quantum mechanics, in which if any particles, electron present inside atomic species, nuclei species, to express its value, that is of unity. For the calculation of mixing coefficient C1 and C2, which gives us the necessary information to us for the calculation of, for the formation of strong bond formation or weak bond formation by means of bonding energy level or anti-bonding energy level, that is for symmetric and antisymmetric molecular orbitals. Now to calculate the value of mixing coefficient C1 and C2, suppose particles or electron which is present inside of, that is of atomic skeleton, its value to express as, that is of unity. I mean to say psi molecular square d lambda is equals to 1, say that is of equation number 6. Let us proceed here. In our previous lecture, dear students of B.Sc Part 3, once again I state the fundamental equation of psi molecular orbital, that is of C1 psi A plus C2 psi B, where psi A and psi B denote the atomic wave function for A and atomic A and B, I mean for hydrogen atom A, HA and HB respectively. On squaring d lambda is equals to, that is of 1, put down 1, equation number 6, we are having equation number 7. Dear students, by simple mathematics here, this whole quantity will now be multiplied, the same quantity C1 psi A plus C2 psi B. On solving here equation number 7, we calculate, we are having the value of C1 is equals to 1 upon root 2 plus 2 SAB, C2 is equals to 1 upon 2 minus 2 SAB, where SAB denoted here, that is of overlapping integral here. C1 for mixing coefficient for bonding, C2 mixing coefficient for antibonding. When we are using C1 plus C2, we have 4, that is of bonding molecular orbital, and that is of for antibonding C1 is equals to minus C2. In our previous lecture, once again I repeat the necessary previous equation, in which for that is of symmetric wave function we have calculated here psi S is equals to psi A plus psi B 1 upon 2 plus 2 SAB, and E1 is that is the bonding energy for E1 is equals to H double A plus HAB 1 upon 1 plus SAB, HA, HB, SAB. These are using here various Coulombic integral, resonance integral and overlapping integral. Similarly for antibonding molecular orbital, on calculating, on solving equation number, that is of 7, we are having here for, that is of antibonding, that is of psi 2 is equals to psi A is equals to psi A minus psi B 1 upon root 2 minus 2 SAB. U2 is equals to HAA minus HAB 1 minus SAB. Say that is of equation number that is of 11. Finally, that is of 80% LCO treatment for H2 plus ion hydrogen molecule ion. We have derived here, we have explained here. When a graph is plotted between bonding molecular orbital energy levels and anti-bonding molecular orbital energy level, the final that is of LCO diagram we plot here on the blackboard here. EH field that is of energy level diagram for hydrogen atom. ES is equals to E1 is equals to 1 plus HAB minus 1 into HAA plus HAB. Here that is of E1 is equals to, on solving one can write numerator and denominator 1 plus divisible by 1 plus SAB. So one can write here that is of 1 plus SAB minus 1, and this quantity HAA plus HAB will remain as such. And for that is of anti-bonding energy levels, we are having EA is equals to U2 is equals to 1 minus SAB. Here that is of HAA minus HAB, here 1 minus SAB. On solving here, one can write here that is of 1 minus SAB minus 1 HAA minus HAB. Dear students, the energy level diagram for hydrogen molecule and H2 plus one can plot on the blackboard here, in which that is of lower energy level to show the value of symmetric energy level and upper energy level to show that is of anti-bonding energy levels here. By the combination of various integral, overlapping integral, Coulombic integral, and that is of resonance integral here, the energy level diagram actually have been shown here, that is of EH, in which the derivation of for the calculation of H2 plus ion. Dear students of B.Sc part 3, we calculate the value of C1 for bonding, C2, and that is of psi 1, psi S energy level of E1, and that is of psi 2, psi A E2, and finally we are near about of the graphical representation for hydrogen ion. And in our previous lecture, once again I repeat here the various mathematical conceptual, including secure equations, matrix form here, normalization condition here, the LCO treatment we apply here, that is of for H2 plus ion. Now very special and amazing lecture I will proceed for the treatment of LCO by using here that is of electron charge, that is of distribution for bonding and anti-bonding molecular orbital here, and what are the essential and necessary condition for psi bonding molecular orbital square and psi anti-bonding molecular orbital square. We will proceed, we will deliver it, that is of tomorrow. Thank you very much.